Hi everybody. Alright, what we're going to do in this video is a chi-square for dependence. Now on a previous video that was made, we did a chi-square for independence, and in that you had to use at least for this example, a 2 by 2 contingency table. Well, in the chi-square for dependence, you don't construct a contingency table because there's only one column of observed data. Now this is a classical example. A person rolls a dice 60 times and recorded how many times the dice faced up for the 6 numbers of the dice. Now you got to establish your hypothesis and your null hypothesis. In this case, the roll of dice for numbers are independent and are not related. Remember, the hypothesis in chi-square, null hypothesis is always an independent one. And for the alternative, the roll of the dice for numbers are dependent and are related. So we want to see if we're going to accept or reject the null hypothesis. Now, your first act should be is to set up your working table, and as you can see here, these are the groups, these are the dice, and 6 is going to play an important part for the expected values. We have our observed. So in other words, a person did roll the dice 60 times, and this is what he came up with for the numbers that are on the dice. Now, so you want to get that in there. Now, on the top row, you want to put your chi-square operations. So you got your observed, you got your expected, which we'll do in a second moment, and then you want to have a column for observed minus the expected. You want to have a column for the square of the observed minus the expected, and then to conclude, to get to the chi-square statistic, you now need to take the squared number and you need to divide it by the expected number, and we'll go over that in a moment. Okay, so once you got that part done, and you now want to set up your column table for your results or what you're looking for. So again, you want to have your chi-square statistic. You want to figure out the degree of freedom, and since we have 5 groups here, that's again 6 minus, we have 6 groups. 6 minus 1 equals the degree of freedom, which is 5. You should already establish your alpha level or your probability level, and in this case, again, we're working with 0.05, which is standard. And eventually, we're going to have to figure out the chi-square critical value, and the dependence always looks at the right side of the bell-shaped curve, and of course we're going to have to figure out the p-value using the chi-square test, but we'll do that. I'll show you that in a moment. Alright, now you've already set up your table. You already know the summary data of the dice. Now you need to set up your expected column. Luckily, we have 60 here, which is easy to do, because 60 would eventually, you expect after each roll at least 10 times 1, 2, 3, 4, 5, 6 number would show up. But the way I did it was, you take in this case B8. That's your total is 60. So you got to work with the total here, and it was divided by S7. Mainly because there are 6 groups. So you take your max and you take 60 divided by 6, and that equals 10. And if you go to each expected cell, you will see this. Now what I did, because I knew that I did an autofill, and you can do the autofill by placing your cursor in in between the letter and the number, and you press F4, and now give you an autofill. The reason I did the autofill, because we were using the same numbers, the 60 total and the 6 for the number of groups. So I knew that if I did the autofill, I'd be able to fill it up real quickly. If you need to learn more about autofill, I suggest you Google autofill on using Excel. Then once you got that, then the rest of the operation is you want to take your observe, in this case B2 minus the expectant, and this case would be C2, and that's how we came up with 1 for this column. And the same is with the others. You can click in the individual cells to see them. Then again, all you do is take the number from this column and square it. And again, a square is just a number times the number. As you can see, I did that for all. And other practice problems, I showed you that you can go up to in formulas, go to math and trig, and you can see the power function right there, and you can use that device. Then, of course, once you finish getting the squares, now you have to take the square and divide it by the expectant of that particular group. In this case, 10 will be the number that will be used on all. So in this case, it was E2 divided by C2, or 1 divided by 10 in this case, and this is the number you came up with. And you can do it for all the others that are like that. Okay, for that column to come up with these numbers. Then to get to your chi-square statistic, you just click you click into the box. Of course, it would be empty. And then what I did, I just went to formulas and I used the auto sum, and that added up the numbers for me. So my chi-square statistic is 5.6. 5.6. And then now we went to critical value. So the critical value we'll use, this is what we came up. We'll use this function here. So if I was going to do it again, I can type in CHSQ dot INV dot RT. Let's see if that worked. Okay. CH. There we go. Let's go this one. Now it's asking for the probability. That's your 5. And, oh, excuse me, that's your alpha level there. And then your degree of freedom, that's your 5. And let's see if I come up with the same number. Yep, came up with the same number. So that's how you get your critical value, because you want to compare the chi-square to the critical value. And your p-value, it will use the chi-square test. Oops. Chi-square test. Now it's asking for the range. That's your observed range. Don't use the labels or the total, comma. And it's asking for the expectant, just like we did with the independence procedure, parentheses. And here we have the same number. So since the p-value of 0.34711 is greater than the alpha level of 0.05 in the chi-squared statistic, we'll fill this in, of 5.6 is less than the critical value of 11.0705. That's your critical value. That's your limit, except the null hypothesis. Because the probability level and the chi-square statistic fell, if you draw a bell-shaped curve, it fell within the except the null hypothesis range. So the rolling of the dice numbers are independent. In other words, they're not related. They don't influence each other of what number you're going to observe every time you roll the dice. Try this on your own. Get a dice, roll it 60 times, and see if your numbers agree with this number, and then do a chi-square. So now you can try this. See if you can replicate what I just did. There are 2 more exercises. See if you can replicate what I just did. Pay attention to the to the direction. Try to replicate. I'm already giving you the answers, but at least now you know, and try to replicate what I got there. And here's another one that you can try to replicate. A little bit more complicated because you're going to have another column here. All right, but you can read all about it. All right. So good luck with this, and see what you can do. All right, that's about it. Doc Chasen signing off.